Hello, welcome back. In this segment, I wanted to prove to you that the Cipher cipher that we saw earlier is a permutation. Let me explain more precisely what I mean by permutation here. So very quickly, we can recall that the Cipher cipher can be modeled as follows, right? Some function f, which takes the key and a character to be encoded, okay, some number, and we do x plus k in some mod m. Okay, so if we are working with English alphabet letters, then we have mod 26. In general, you could say mod n. Okay, n can be 26 because there are only 26 alphabet letters A through Z. You could use other languages. Maybe those languages have different values for n. So n is a parameter you could choose. In English, n is 26. Okay. What it means is that we encode A to be 0, B to be 1, and all the way Z to be 25. Okay, that's our message that we would like to encrypt. All we are going to do is just add k positions to the input, and that's how we defined the Cipher cipher in the previous segment. Okay, why is this function a permutation? We can view it like this. Okay, every k, what are the possible values of k? K can be 0 through all the way n minus 1, right? Because we are working with modular arithmetic. Okay, so we can view like this. Let's say the key is 0. Okay, and what is the permutation we get when we apply 0 key? Okay, well, 0 key means the message is not even encrypted, meaning your x is same as the input x is same as the output, because adding with 0 has no sense. We could say on the first row, we could write all the values for x. X can be 0, x can be 1, 2, all the way until n minus 1, right? Those are the possible values for x in modular arithmetic context. When the key k is 0, this is the key, okay? There is no change, meaning 0 will go out as 0, 1 will go out as 1, 2 will go out as 2, and n minus 1 will go out as n minus 1. Okay, this is one possible permutation. Okay, what about if the key is 1? The key is 1, 0 will become 1, 1 will become 2, and so on. So we can write it as follows. Your input is 0, 1, 2, all the way until n minus 1, right? And let's reason about what happens when we add by 1. When we add by 1, because the key is 1, that means 0 becomes 1, 1 becomes 2, 2 becomes 3, and so on. And n minus 1 plus 1 will become n, which means 0 because in mod n. All right. So we can see that this is another permutation, and so on. So how many permutations we will have? We will have sigma of n permutations, meaning 0 through n minus 1. All right, 1 will go to 0 because 1 plus n minus 1 is n, which is same as 0 in mod n. And what about n minus 1? N minus 1 will go to n minus 1 plus n minus 1, which is nothing but minus 2, which is n minus 2. Okay, so basically this is the transformation we have. And how many I have written? All the way from 0 to n minus 1. That means there are n permutations possible. Okay, so if we were working with English, we will have 0 through 25. That means there are 26 permutations. Okay, before I close this, I need to explain to you why I call this permutation. I need to show to you that this particular row, the no two entries are the same. Okay, that's important. Otherwise, it can't be considered as a permutation of the previous thing, right? You can't, for example, let's take this sigma 1. 0, 1, 2, 3, n minus 1 is there. And all the values below are also from 0 through n minus 1, just rotated or reorganized a little bit. Okay, that's basically what we are talking about as a permutation. Okay, permutation means just rearrangement of the input letters. Okay, so for that, we need to convince ourselves that no two entries are the same for a particular key, which is easy to see. Suppose let's take two entries that are x1 and x2. Let's assume they are equal for some reason. Okay, let's see what we can conclude. Suppose these two are equal, what will be the value now? What can we say about x1 and x2? We need to prove that x1 is equal to x2. Suppose this is equal, then we know this is nothing but x plus k mod n in mod n. I'm not writing mod n again and again. Is equal to x2 plus k in mod n. Okay, we can do subtraction of k on both sides. That's allowed in modular arithmetic, which means our x1 is equal to x2. So this tells us that no two entries of the second row is equal. Okay, that's basically what I'm trying to show to you. And since the input lengths are finite, meaning there are only n entries, that tells us that we were able to show that this is a one-to-one function. Okay, you have a finite set, two sets are finite, and we have to do one more thing to show it's an onto function. We need to take an element and show a reverse, right? So let's take an element here. Okay, let's take an element y. And how can we get back the input x? Easy, right? How was y generated? Y was generated by computing x plus k in mod n, right? I'm not writing mod n again and again. And we can rewrite this as y minus k is x. Okay, so we do know that we can if you find an element y, okay, if we are given an element y, to find the inverse in this direction, all we have to do is subtract a k from it. Okay, that means given any element, we are able to go back, and we found out that no two elements are equal in the range set. This is the range set, right? Therefore, we can conclude that this particular mapping is a bijection, meaning permutation. Okay, that's basically it. If you are familiar with group theory, you would know that this is a permutation group, okay, through composition. Okay, but don't worry if you don't know that at this point. But this is basically the group theoretic view of Cipher very quickly. Okay, so let me now show to you how you could check this by writing a little Python program. So let's write a little Python program and to do this hands-on and make sure that we see the permutation. Okay, so we need to define a function f first, which takes two things: the key and the data. Okay, the data is just one number in because the Cipher is stream cipher. Okay. Okay, so what does it do? It returns. Oh, I should have done one more thing. I should define my function f taking key x and the modulus n. Okay, I use capital N, but usually in programs we use small n. Okay, return x plus k mod n, right? That's the encryption function of the Cipher. And now we generate a permutation. Let's generate permutation. And we want to generate permutation for all possible input x. So we fix the key and the modulus, and we write a little for loop that will run for all elements in the range of modulus, to call the function f for the key k for the input x on this modulus n, and we will print the input message to the key and the message, and we will print the mapped or the permutation, basically the corresponding value. Okay, all right, let's now call the gen permutation function for, let's take simple key to be 1, only one position we shift, and we will work with mod 5. Okay, let's assume we have only 5 alphabet letters in our language. Okay, so as you can see here, the first column here is 1 1 1 because we are treating key to be 1. 0 get maps to 1, which is good because we are just shifting by one position. 1 will shift to 2, 2 will shift to 3, 3 will shift to 4, 4 will shift to 0. So this is one permutation. Now we can generate more permutations. Suppose you wanted to see when we shift by 2 positions. Okay, so 0 map to 2, 1 map to 3, 2 map to 4, 3 map to 0 because 3 plus 2 is 5, 5 mod 5 is 0. So we can see that this function f is actually generating a permutation. Okay, that's basically it. It's a very nice function to study, and it's good introduction to the notion of modular arithmetic and additive group. Actually, this is a group in addition. Let me explain that a little bit more clearly. This set Zn, made of numbers from 0 through n minus 1, forms a group under modular addition. Okay, what it means is that if you take any two elements and add as follows: a plus b means you compute a regular addition, but you compute the modulus after that. So basically a plus b mod, we define it like this. Suppose you define the group addition plus as follows: is a plus b mod n. Okay, this is how you are going to add. What it means is that you add two numbers and you do a mod n so that the answer will always be a number between 0 and n minus 1. Okay, that's the closure property. So closure is clear from the definition of modulus. Okay, Any two numbers, if you pick from the set and add, the answer will be an element in the set. Okay, what is identity? 0 is identity, because if you add any element with 0, you get the element. So 0 is identity. What about associative? Plus is associative, right, in regular arithmetic. So associative property is true here as well. What about inverse? So for an element A, what will you add to get 0? Because 0 is identity element, right? It turned out that if you just think a little bit, you can easily find out this in mod n. Remember, plus is defined in mod n. So what about n minus a? This a and this a will cancel out, right? N is same as 0 in mod n. So inverse of a is n minus a, the additive inverse. Okay, so as you can see here, the set Zn made of numbers from 0 through n minus 1 forms a group under addition. Okay, addition is defined in a special way, modular addition. All right, that's basically what I wanted to show to you, that the Cipher cipher is actually a permutation, and Cipher cipher is can also be viewed as a set of permutations, and they form a group. Okay, as we talked about. Thank you. That's it.